Okay. Hi everybody. Today we are going to make a IMAT solving a past exam 2022 physics and mathematics section, question number 51. Okay, so we have here a question. Simplify this mathematical equation and see what's the correct answer. Each question we will have like some relevant background equations, maybe they will help. So I wrote here what is relevant, and let's solve this question. So we have here 9 in the power of 2, 10 in the power of 8, minus 10 in the power of 8, which is the same power, 1.2, 10 in the power of 11. Down here we have 10 minus 1, which is like 10 going to the denominator, minus 9.8. Let's simplify it without too much complication. We have here 0.1 minus 0.098. Okay, so actually we can rewrite this like 0.002. It can be written 2 multiplied by 10 in the power of minus 3, because 1, 2, 3. Okay, let's continue. Let's take it from here. So we have and let's take up the 10 minus 3 to the denominator. So we have like 10 in the power of 3 instead of minus 3 in the power of 3. 9 square minus 1, 81. 9 square is 81. Again, 10 in the power of 8 multiplied by 81 minus 1 plus 1.2, 10 in the power of 11. All this divided by 2. Let's continue. 81 minus 1 is 80. You have 3 and 8, which is 11, multiplied by 80 divided by 2, plus 1.2 divided by 2, multiply 10 in the power of 11. By the way, don't forget that all of this have the root of 3. Okay, so we have here 40, 10 in the power of 11, plus 0.6, 10, no, 8, sorry, 8. Here is 8, and here is 8, and you have 0.6, 10 in the power of 11. 40 we can take 4 and add one number to the 10, 9, and 0.6 we can make it 6 and add subtract 1 from 11, we have 10. And as you offered before, I remember last time, if you want here the 10 to be in the power of 9, so you can make it 60, and you will have 64. So let's continue. So you have 60 multiplied by 10 in the power of 9 plus 4 multiplied by 10 in the power of 9. So we will have here like 64 multiplied by 10 in the power of 9. Don't forget that we have here square root of 3, which is 1 divided by 3. So 64, the square root of 3, the root of 3, 10, 9 divided by 3. So how much is 64 in the power of 1 divided by 3, and so we have here 4, and here we have 10 in the power of 3, which is 4,000. No, 10 in the power of 3, 4,000. 9 divided by 3, this is 4, 3, 4,000. So let's go back. I think we have here we missed something. So what we missed, tell me.
10 to the power 3. Yeah.
So this one not 11, this one is like 14, yeah. This one is 14, so this one is 13, and here it is 12. So this is 12, so this is 4, and this is 40,000. So the answer is A. Okay, great. Let's go to the second question. Okay, question number 52. Read it, please.
Yeah. A block sliding along a flat horizontal surface at an initial velocity of 2 meters second experiences a constant resistive force of 4 newtons that brings it to rest in a distance of 2 meters. What is the mass of the block?
Okay, so let's understand the question. We have here a block sliding along a flat horizontal surface. So you have here a horizontal surface, and you have a block sliding along. Sliding along is like this. So we have a velocity here. V is velocity, and the velocity is 2 meters per second. Experiences a constant resistive force. So let's change the color for the resistive force. A resistive force is actually always a reaction to the velocity. If there's no power or velocity, it's like not working. So, and this is a force which is yeah, but it's dependent on, you have here mg, the mass, and the gravitation acceleration. This is a force, yeah, and this force, by the third law of Newton, creates the natural force N, okay, and the natural force N creates the friction. So we have the friction here. Let's see what they say also. Experiences a constant friction of 4 newtons. This is newtons is the what unit? Yeah, the units are newtons. And if you take so let's remember the Newton force. So if you have F equals ma, the second law of Newton, so this is a Newton unit, and this is mass, this is a kilogram. A is meter second square. So Newton is actually kilogram meter second square. You can also write it everything in the nominator minus 2. It will be something like this. Okay, that brings it to rest in distance of 2 meters. So after 2 meters, let's change the color also here. So after 2 meters, the velocity will be 0. Okay. Okay, so let's remember the 4 laws of motion. Okay, let's write them down. Okay, so I move this here. So we have the 4 laws of motion, kinetic equations. Yeah, the 4 equations of motion. So it depends what variables you have available. So v, the velocity, equals u, which is the velocity in the beginning, plus a, acceleration and time. You have s equals ut plus at square by 2. S is distance, like the usual, you can also write d if you are used to d. V square equals u square plus 2 times acceleration with time with s distance, and the distance is actually the average speed multiplied by time. Yeah. So let's see what equation we will use here. We have the initial speed, 2 meters per second. We have the final speed. We have the distance. So initial speed, final speed, distance. And we can find A. What is the mass of the block? Okay, if we find A, we can use a Newton law. This one.
Yeah.
If we have A and the F, we can find the mass. Let's do it. So we have the plan. Let's start. So let's use V square equals U square plus 2 times AS. V square, the final speed is 0 actually. Yeah. Sometimes people get confused. They want like the V to be more high because of acceleration, but here we don't have acceleration. Yeah. We have the acceleration. So the initial speed actually it is like the 2 meters per second. 2 times acceleration, we will find it, and the distance is 2 meters, so we have 2 here. That means that we have 2 divided by 2. This is half meter square meter by second square. This is the unit. Okay, so the F, what is the F? The F is sigma F actually, which is like the summary of all the forces. Okay, the total of all the forces. You have no force to this direction, just an initial push, so you have minus force. So you have here minus 4 Newton equals the kilogram. We will find out. M we don't know. A we know, which is half, and also the A is minus, the vector also minus, because it's the opposite direction of the motion. So M equals 8 kilogram, and this is 8 kilogram. It is E. Okay, so the answer should be A. So I think we missed something here. I think this is the square here. So because of the square here, this is 1, and here is it's 1. So actually you have minus and minus. Actually this is also minus. Yeah, minus, this is A equals minus 4 on 4 equals minus 1. So why minus? Because the motion is to the right, but the acceleration is to the left. It's in the opposite side, and it's exactly the side of the force also. So you have here 4 kilograms. The right answer is A. I think in this exam all the right answers are A, so we have 4 kilograms. We missed this square. Okay, let's continue. Any questions? Next. Okay, let's continue. We have find the area enclosed by the 3 lines. Let's see these 3 lines. We have 1, so the 3 lines are y equals 0. This is this one. 2x minus 4. This is minus 4. This is slope of 2. This is 2, and 11 minus x. This is 11. This is 11 minus x. The area which is enclosed by all of them, this is this area here. Yeah, so let's find the points. We have A, B, C. This is the point, A, B, C. A is 2.0, B is 11.0, and C we need to calculate. So this is 11 minus x equals minus 4 plus 2x. You have 3x equals 7. No? Yeah. 3x equals not 7, equals 15. So x equals 5. Yeah. This is 5. And substitute it here, so it will be 6. So C is 5.6. Let's calculate this area. So you have here 11 minus 2 multiplied by 6 on 2, 9 multiplied by 3, 27, A. Okay, so question number 54. Let's go.
A fixed mass of an ideal gas is compressed slowly so that its volume halves and its pressure doubles. Which of the following statements about the gas after this change is or are correct?
Okay, before you read the statements, let's understand the question. Okay, so let's solve this, understand the question. Yes, what do you think? What equation to use?
We're going to use for the first one the ideal gas equation.
Yeah. PV equals nRT. This is ideal gas equation, which here, what is P? Pressure, volume V, and T is the temperature, correct?
Yes, and is the moles and R is a constant.
Okay, so if V halves goes to half and P doubles, so actually we have here what? The same, right? Constant. So T is also what? Not changing here. So let's see the first statement.
The final temperature of the gas is the same as before the change.
Correct. The second one.
Yes.
Second statement.
The final internal energy of the gas is the same as before the change. This is also correct.
The
For an ideal gas, internal energy, which is
U.
U
Yeah.
proportional to the temperature.
Yeah, U is proportional to the
Is
temperature.
unchanged, then
Yeah.
internal energy is also unchanged.
So this is correct. What about 3?
The final mean kinetic energy of the particles of the gas is the same as before the change. This is also correct.
Correct.
Because mean kinetic energy of an ideal gas particle depends only on the temperature. So if the temperature is unchanged, the kinetic energy is constant.
So the answer is A, everything constant. Okay. So actually what happened here, if you take a piston and you pressure it and make the volume half, and also the pressure goes to half, the temperature and inner energy and the kinetic energy mean will not change. It will be constant. Okay, let's continue. Okay, next question. Read it, please.
Which of the following is a simplification of the formula?
Let's see. So we need to simplify it. So what we wrote before today, a square, b square, these things, I think we can use it here now. Let's do it. Okay, so how to solve this? We will common multiplier x minus 6 minus, here we have x plus 3. So what about the numerator? So if you have here x minus 6, it should be also here, you know, logically. And here x plus 3, we just need to find the second part. Because here you have 2, so for sure this is 2x, and here for sure this is 3x. So the question is, this is plus how much and this is minus how much. How I know minus? Because here you have 3 minus 1. This is minus 1 again, because minus 1 multiplied by 3 is 3. Here minus 6, I think it should be plus 3. Let's see if it's work. Let's see if it's like correct. Test it. The 2x plus 3 multiplied by x minus 6 equals 2x square plus 3x minus 12x minus 18, which is exactly what? The same. So this is okay. Let's check the second one. 3x minus 1 x plus 3. Let's see if it's correct also. You have 3x square, you have minus x, you have plus 9x, and you have minus 3, which is 3x square plus 8 minus 3. This is also correct. So we can take it from here, continue. This cancel out. This is cancels out. We have x, 2x plus 3. We can, I think, I like simplify it a little bit. So we have 2x divided by x plus 3 divided by x minus 3x divided by x plus 1 divided by x. So this also cancels out. So we have 2 minus 3. This is minus 1. And 3 plus 1. This is for x, which is this answer. Okay? Good. Next question. Question 56. Yes, please.
An 18-volt battery and a 3-ohm resistor are connected in series with each other and in series with a parallel arrangement of a 3-ohm resistor and a 6-ohm resistor. What is the current in the battery? Assume that the battery has no internal resistance.
Okay, let's do it. So we have 18 volt series with 3 and what also in series.
With a parallel arrangement.
Nice. 3 and 6. Okay, so 3 and 6 parallel arrangement. What we have here, 1 divided by r equals 1 r2. This is a parallel, correct?
Yeah, this is a parallel resistor law.
Yeah. And in series, what we have r equals r1 plus r2. So let's open a new here. So 3 and 6, we can change it by what? 1 divided by r equals 1/3 on 1/6, which is 2 plus 1 on 6, 3 6, which is half. So you have r2. So you can change it by 2. Okay. Next, you have 3 and 2, and the law here is just what? Yeah, 3 plus 2 equals 5 ohm. So you have 18 volt, you have 5 ohm, so 18 volt on 5 ohm, it's actually 3.3 fifths, which is 0.6 ampere. So you have here 3.6 ampere, and this is the answer number A. Okay, so let's see. Also you can calculate here. If you have here 18 and 3.6 ampere, you can multiply 3 multiplied by 3.6, which is like 10 point, this is 10.8 volt, and this one 7.2 volt equals what? 18 volt. Okay, on each one of them. Also you can calculate the current here and here. You have here 3.6, and here the volt is, as we said, 7.2. okay, and this is 7.2 volt. You can divide 7.2 divided by 6 is around 1 point something, yeah? I think 1.2, this is 1.2, and this should be 2.4, I think 2.4 ampere. Let's draw it all together. So you have here 18 volts. The current here is 3.6 ampere. This is 3 ohm, this is 3 ohm, this is 6 ohm. The voltage here, this is, how much we said? 10.8 volt. Here you have current 2.4 ampere, and here you have current 1.2 ampere. Here voltage is 7.2 volt, this is 7.2 volt. Okay? Nice. But 1 second. Yes.
The mean of 5 non-zero integers is 12. The median is 24. What is the maximum possible value for the largest number?
The largest number, the maximum of the largest number. Okay, let's understand firstly what is going on here. So you have x1, x2, x3, and 4, and 5. Their mean is 20. You can say also that the summary of all of them is what? Is 100, like 5 multiplied by 20. Okay? The median, which is x3, yeah, is 24. Okay. The median is 24. So, because the median x3 is 24, it means that x4 and x5 are bigger, and x1 and x2 are smaller. So, if you want x5 to be very big, yeah, the maximum, you need x1, x2 to be what, and x4 to be what? The minimum. So it's already very simple, because the minimum is 0, I think non-zero, yeah?
Non-zero. Yeah,
Positive, integers, so like it's 1, yeah? So we have here 1, 1, and 24. The smallest one equals, it can be equal to the median, yeah? So it's 24. So let's calculate. 1 plus 1 plus 24 plus 24 plus x5 equals 100. x5 can be how much? 25, 25, I guess it's like 50. Yes.
So x5 is 50.
Yeah? Okay, that's easy. Okay, next question.
A long single coil of wire is connected directly to an ammeter, which is used to indicate the direction of the current in the wire. As the end pole of a bar magnet is inserted into the left-hand end of the coil, the ammeter indicates a current in a certain direction.
Okay, continue.
Actually, a current in the same direction.
Okay, let's understand the question here. So you have a single coil and you have a magnet. You know, magnets have the north and the south. So you have the north and the south. So the north enters the positive, yeah? So you have a positive magnet going inside. So you have like Faraday law, and you have Lenz low. Basically, the current should produce the opposite magnetic change, flux. So let's think about it. So if you have a circle by the right hand law, so if it's like counterclockwise, yeah, counterclockwise, it will be up. If it's clockwise, it will be down, yeah. If it's clockwise, it will be down. So to make the magnetic field of the current left side, it should be counterclockwise, yeah?
Yeah.
Counterclockwise. Oh, long word. So, how to create the same counterclockwise? We can, what to do? We can also have the south side of the magnet, yeah,
into the right hand.
from the right hand coming to the left side. It will also create the same effect, because also you have the positive side to the right, so the flux and the by Faraday and Lenz's law. Also it will be counter clockwise, so it will produce the opposite side to the left. So the answer is A. Read it please.
Inserting the S pole of the magnet into the right hand end of the coil is the same
Exactly.
as inserting the N pole to the left hand of the end of the coil.
Exactly. Next. Okay, let's read this question, number 59.
The diagram shows two concentric circles, both with center O.
Mm-hmm.
The angle of the shaded sector is 6.
Yeah, yeah.
The radius of the larger circle is 50% greater than the radius of the smaller.
Like 1.5 times, yeah? Like 1.5 times, yeah? Okay.
Yeah.
Mm-hmm.
The total area of the two polar circle is 36 pi centimeters square.
So actually, if it's 36 pi, so it's like 6 square pi. So this is like, this is 6, yeah? Continue, please.
Yeah, the area of the shaded
Wait, if this is 6, so this is what? This is 9, yeah? 1.5 times, yeah? Okay, okay.
The area of the shaded sector is 27 pi divided by 8 centimeters.
The area of the shaded sector is, okay. So, we need the angle. Okay, so 27 pi divided by 8 divided by actually the full area, which is like 9 square pi, yeah? This is the full area of the angle. This will be theta divided by the full angle is 2 pi, correct? Right? This is calculation logical, yes? So let's divide here the pi's. You have here let's make it more easy. So theta equals 2 times 2 pi. 27 is 3 times 9, correct? Divided by 8. All this divided by 9 multiplied by 9. So let's make it more simple, like this, divide by this. This 4. So you have 3 divided by 4 by 9 multiply by pi. This is 1, this is 3. 1 times pi. 1/12 of pi.
Yeah.
Okay, what does it mean? What is this value in what 1/12 of pi? This is 15 like degrees, I think. Yeah.
Yeah,
We need to multiply by 360 degrees and take out the 2 pi. So we will transform the radian to degrees. So pi by pi is 24, 360 by 24, this one is 15. By the way, we can in the beginning, instead of 2 pi, make 360. If I would recognize that the answer is in degrees, I would make it from the beginning 360. So you have like 360 theta from 360. This is 27. How much we have there? 8 divided by what? 81. 9 square pi. So we have theta divided by 360 equals 27, which is 9 multiplied by, well, we make it more fast. 27 divided by 8, 9 square pi, it cancels out. So you have here divide by 9, this is 3, and this goes by 1, this is 3. So you have theta divided by, this you have 1 divided by 24. Yeah, so you have theta 360 equals 124. So theta is 360 divided by 24, which is 15 degrees. Okay? Okay. Okay, last question. Let's do it. 1 minute. Yeah. Okay.
The simple pendulum of a tall clock swings freely backwards and forwards so that it passes through the vertical position at 1 second interval.
Mm-hmm.
Assuming that the motion of the pendulum is simply harmonic,
Mm-hmm.
what is the length of the pendulum?
Okay.
Take the gravitational field strength to be 10 newton per kilogram and take pi
Square to be 10. Okay, pi square also 10. Okay. Okay, let's do it. So you have a pendulum of a tall clock swings freely. Let's try to illustrate this. So you have like the right side, the left side, and it's swinging left and right in a harmonic, simple harmonic way, which is like left and right in a harmonic way, so that it passes through the vertical position at 1 second intervals. Okay, assuming the motion is pendulum is simple harmonic, what's the length of the pendulum? Okay, let's first write down the forces that we have here. So actually here we have like mg, there's no vertical force here, 0. Here we have mg sinus alpha, this is alpha, and here the same, we have mg sine alpha, but mostly we work in this simple harmonics with energy. Yeah, so let's calculate it. Okay, so the law is like time equals 2 pi square root of length on gravity. So you have 2 seconds because it's like 1 second half round and another 1 second, so it's 2 seconds. You have the length on 10. So pi square equals L on 10, so L equals how much? No, 1 minute, 1 second. I solved too much fast. So we have like 1 divided by pi equals square root. Let's make it square, so you have 1 pi square equals L on 10. So you have 10 on 100. 10 on 10. They said pi square is 10, yeah? So which is 1. The answer is 1 meter. Okay. So that's it for today. We solved the math and the physics section of IMAT 2022.